Hey there, everyone. I haven't done one of these in a while, but just going to talk a little bit about the severe weather setup tomorrow. And yeah, I'm going to lay off the snowfall discussion here, at least here in Colorado, just because I'm going to be brutally honest. Kind of once it gets towards the end of April, my mind kind of just gradually shifts over to severe weather, if I'm being brutally honest. So maybe I'll talk a little bit about towards the end of the video, but yeah, just going to address the severe weather setup across the central and southern plains tomorrow. Taking a look at current surface observations, you can see we have a low kind of centered over eastern Nebraska, western Iowa, and that's bringing Iowa, Wisconsin, Minnesota, even Illinois some severe weather. A couple tornadoes, definitely some large hail and some damaging winds into this evening and also this afternoon. Associated with that, there is a cold front. You can kind of see on the back end of it there. That'll eventually sag southward, and it will push its way across parts of Kansas, and where that cold front eventually stalls out and retreats northward as a warm front, and where that becomes stationed tomorrow, that will certainly become a focal point for severe weather tomorrow across south central Kansas, even in parts of western Oklahoma. Also kind of a weak dry line feature here. Gage, Oklahoma here, this 82 over 43 degrees, 15 knot southwesterly flow, and then just to the east of it, a 53 degree dew point. I believe that's Weatherford, Oklahoma, and kind of a southeasterly wind. So not really a strong dry line, but a subtle feature there. So yeah, just a pretty quiet day across the central and southern plains, which is probably a good thing considering they were certainly active yesterday, and they will probably be active tomorrow and even into Friday. Taking a look at this is GO16 mid-level water vapor imagery. I believe it's 6.9 microns. Anyways, channel 9. This is from the University of Wisconsin. They throw together a lot of good stuff. You can see two very well-defined lows, and you can see the one over Iowa that I just showed you on surface observations, and that's bringing some severe weather to the upper Midwest. And this is really our system of interest in tomorrow, this upper-level low that is churning over parts of the Great Basin, Idaho, Nevada, Utah, and even into Wyoming. And I believe they actually saw some snow out of this earlier today, and maybe even some lightning with that. So this is actually a pretty potent system, as I'll show you in just a second. We'll expect this to dig a little bit further south, and eventually it will lift off to the north and east. But this is the large-scale forcing for ascent that we will experience across the central and southern plains tomorrow, and even into Friday. Another just kind of a neat feature here is you can see this very warm and dry air in the mid-levels being advected from the southwest over from Texas, West Texas, and parts of Mexico, and that's that elevated mixed layer where we see the deep mixing over the higher terrain. And then as this wave ejects off to the north and east, it will advect those steeper lapse rates in the mid-levels with it. So as we know, when we put steeper lapse rates in the mid-levels and we put that atop a moist boundary layer, we generate buoyancy simply because there's less dense air at the surface, and then dry, dense air aloft, and that generates buoyancy or convective available potential energy. So just kind of it's a very simple explanation of why the central and southern plains, or just the plains in general, is just such a favorable environment for strong thunderstorms, especially this time of year. But of course, it's a lot more complicated than that, and I don't really want to go off on too much of a tangent. This is just radar, pretty much just reflective of what we saw on water vapor imagery. Although water vapor imagery, that's in the mid-levels, but what we're seeing now is on the surface. Yeah, you can see those thunderstorms associated with that low across the upper Midwest. Even a pretty nasty thunderstorm looks like it's about to slide in just north of Milwaukee, probably bringing some large hail. And it's hard to tell this far out, but just kind of the structure of it, that's what it would look like. But also a line echo wave pattern moving into eastern Iowa and parts of Illinois and Wisconsin. And of course you can see that circulation associated with our system of interest into tomorrow, bringing Idaho, Montana, Wyoming, Utah, and Colorado, western Colorado, some rain and snow showers. Let's see. I'm just going to shift back to from the SPC mesoscale analysis, and I just kind of want to illustrate those the elevated mix laying the steeper lapse rates being convected east off the higher terrain. You can see just from the source region, and we do have a low up here across the Great Basin, and which I'll show you in just a second. That low will dig simply because we are experiencing vorticity advection on the left side of the trough axis. So you can see here vorticity is being advected, which indicates that the trough will dig or propagate in the direction of where that advection is taking place. So we'd expect this trough to dig and eventually lift off to the north and east. But anyways, back to mid-level lapse rates. You can see they aren't quite dry adiabatic, but they're roughly in the 8 to 9.5 degrees C range in the 700 to 500 millibar layer. So, of course, when we place that across mid-60 dew points at the surface, that's create our loaded gun sounding profiles. And those are, of course, favorable for severe weather in the presence of other ingredients, such as deep layer shear, which is usually accompanied by the advection of lapse rates. So just kind of a note there. So kind of cherry-picked a location for where I'm actually going to be tomorrow, or somewhere in this range, in this area, across central and southern Kansas. This is Hutchinson, Kansas. It's northwest of Wichita, I'd say, by about maybe 30-40 miles. And yeah, this is from the 12Z NAM. So this morning's run, and you can see just 12Z, so I think this is 7 a.m. Local time, Central Time. And yeah, we're stable boundary layer, very shallow, moist layer at the surface, and but really not too interesting. And then as that warm front eventually retreats northward, you can see the moisture advection occurs pretty rapidly. And then we also warm some at the surface, and eventually we start to bring those steeper lapse rates in the mid-levels further east or northeast. Doesn't matter, but yeah, look at the just remarkable jump in dew point as we progress throughout the day, and also the strong veering wind profile in the lowest levels of the atmosphere that implies warmer advection, especially as the warm sector kind of engulfs a large portion of the central and southern plains. But yeah, we are still capped at 19Z, so this is a little bit before initiation, but eventually it looks like we erode some of that cap as that wave pushes a little bit further east, that deeper wave that's currently over the western states right now. And also look how the surface winds kind of back with time, or turn counterclockwise with time, and that's probably partially a reflection of the low-level jet that we typically see once we decouple the atmosphere from the boundary layer. So, of course, as a result, that will lengthen our hodograph, and it will also increase our storm relative helicity. So this is a pretty volatile environment for severe thunderstorms, and I would expect, especially with these steep mid-level lapse rates and large buoyancy and large vertical wind shear, large hail, probably giant hail, probably see some cases of that tomorrow. Tornado potential is a little bit more iffy, at least with classic supercells, simply because with this wave moving east, we don't want things to blow up all at once, but the cap should help with that. We do stay capped pretty late into the day, but eventually we erode that by late afternoon, early evening hours. But yeah, this is a pretty scary looking profile for the central and southern plains. Again, this is just one model. The NAM has been fairly aggressive with not only vertical wind shear, but just buoyancy in general. GFS is slightly less so, but all signs are pointing to a pretty active day across the central and southern plains tomorrow. Anyways, let me just go down and I'll just kind of show the little jet in action. We'll zoom in. This is from College of DuPage. They throw together some nice products. You can see by 0Z, we really just see the winds really start to pick up out of the south or southeast, and that will, of course, increase our low-level vertical wind shear, and tornado potential will also increase there as well, especially along the warm front, wherever that parks out tomorrow. Anyways, that really does it for me. I just kind of wanted to give a note, my thoughts for tomorrow's setup, and yeah, I guess snow in Colorado. Maybe I'll do another one of these videos later this evening. Probably not, but just want to talk about severe weather. So everyone be safe, especially if you're heading out there. Please follow the rules of the road, and be safe and courteous, and don't push your boundaries, no pun intended. All right.